in this class we are going to be looking at some things that you need to equip yourself with so that you can understand every topic in mathematics. These things are very, very important. They are very, very important. If you don't understand them, you will keep struggling. So you need to pay attention to this lesson so you can understand these concepts. Okay, so why don't you follow me? Let's dive in. Okay, the first concept we're going to be talking about is the concept of factors and multiples. Factors and multiples. A factor of a number is that number that can divide the given number without a remainder. Okay, so if we have a number like 20, any number that can divide 20 without remainder is called factor of 20. So let's take, for instance, with the example we have 20. The numbers that can divide 20 are 2. Of course, 1 can divide every number, 2 can divide, 4 can divide 20, 5 can divide 20, 10 can divide 20, and 20 can also divide itself. So these numbers that can divide 20 without remainder, they are called factors. Factors divide a number without a remainder. Alright, the next thing we will talk about is multiple. When we talk about multiples of a number, they are numbers we get by multiplying a number by different non-zero numbers. These non-zero numbers, we call them integers. So let's take, for instance, 2. Okay, when we multiply 2 by different numbers, if we multiply 2 by 1, we get 2. If we multiply 2 by 2, we get 4. If we multiply 2 by 3, we get 6. If we multiply 2 by 4, we get 8. Okay, if we continue that way, we get 10, we get 12, we get 14, and that way. So these numbers that we get by multiplying 2 by different non-zero numbers, they are called multiples. Okay, so what are going to be multiples of 4? The multiples of 4 will be 4, we'll multiply 4 by 1, 8, we'll multiply 4 by 2, 12, we'll multiply 4 by 3, 16, 20, 24, 28, 32, and so on. These numbers are called multiples. Multiples. Okay. So the next thing that we need to look at, they are called prime numbers. Prime numbers. What are prime numbers? A prime number is a number that has only 2 factors. Remember, we talked about factors a few moments ago. Factors are numbers that can divide another number without a remainder. Now, if a number has only 2 factors, in the example we took, we said the factors of 20 are 1, 2, 4, 5, 10, and 20. You can see that 20 has 1, 2, 3, 4, 5, and 6 factors. However, there are some numbers that have only 2 factors. Let's look at 3. The only numbers that can divide 3 are 1 and 3. Okay, a number like 5, the only numbers that can divide 5 are 1 and 5. The only numbers that can divide 7 are 1 and 7. So these kind of numbers that have only 2 factors, they are called prime numbers. So prime numbers are numbers that have only 2 factors. So can we now list prime numbers? Let's list a few prime numbers between 1 and 30. So we have 2. 2 is the first prime number. 1 is not a prime number because 1 has only 1 factor. The only number that can divide 1 is 1. So 1 does not have 2 factors. Prime numbers have exactly 2 factors. So the first number that has 2 factors, only 2 factors, is 2. And then we'll have 3. We have 5. We have 7. We have 11. We have 17. We have 19. We have 23. We have 29. These are prime numbers between 1 and 30. We can continue writing to 100. So prime numbers are numbers that have only 2 factors. Okay, so let's move on to something else that is very important. Okay, so we're going to look at the concept we call LCM. LCM. So remember we talked about multiples briefly. We talked about multiples. LCM stands for lowest common multiple. Lowest common multiple. So what does that mean? We talked about multiple. Multiple mean numbers we get by multiplying a number by different non-zero numbers. So if we have two numbers, for instance, we have 2 and we have 6. Okay, if we write the multiples of 2, we have 2, we have 4, we have 6, we have 8, we have 10, we have 12, we have 14, we have 16, we have 18. Let's write the multiples. Let's write the multiples of 6. Multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 2 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 5 is 30. 6 times 6 is 36. So what do we observe here? There are some multiples that we find in 2 and we also find them in 6. Okay, multiples like 6, we can see that 6 is found in the multiples of 2. 6 is also found in the multiples of 6. We can see that 12 is found in the multiples of 2, and 12 is also there in the multiples of 6. We can see that 18 is found in the multiples of 2 and also found. When a multiple is found in the multiples of 2 or more given numbers, that multiple is called a common multiple. Common means it's found here and it's also found there. Okay, if it's found in 2 but it's not found in 6, it's not common. If it's found in 6 but it's not found in 2, it's not common. But when it's found in both 2 and 6 at the same time, then it's a common multiple. So a common multiple is a multiple that is found in more than 2 numbers, in the multiples of more than 2 numbers. Okay, so what then is lowest common multiple? You hear the word lowest. When you get the multiples, the smallest of them is the lowest common multiple. So in this example that we're using, 6 is a multiple, is a common multiple. Common multiple are 6, 12, and then 18. Which of them is the smallest? You can see obviously that 6 is the smallest of the 3 multiples. So we can say that 6 is the LCM. So the smallest multiple, the smallest common multiple is the LCM. Okay, so how do we find LCM? But just by what we did, yes, that's one of the ways you can find LCM. So if for instance we're asked to find the LCM, find the LCM of 3 and 6. Find the LCM of 3 and 6. 3 and 6. What we're going to do is write the multiples of 3 and then write the multiples of 6. One thing you need to take note, like I said, there is no need doing something that is not necessary. The first common multiple is always your LCM. So when you're writing multiples, once you get the first common multiple, there is no need to continue to write, because we will always discover that the smallest one is always the LCM. So once I see a common multiple between 3 and 6, I will not continue writing. So don't say I must write and get 3 or 4 multiples and then pick the smallest one. Once you're asked to get LCM, as soon as you see the first common multiple, that is your LCM. So for multiples of 3, we have 3, we have 6, we have 9, we have 12, we have 15, we have 18. Let's write multiples of 6. Multiples of 6 are 6, we have 2. Okay, as you can see, I already have 6 and 6. Once I'm able to spot that, there is no need to continue to write, because I know that even if I have more common multiples, that first one will always be my LCM. So my LCM is equal to 6. That is what they asked me to find. LCM is smallest one, and LCM is always the first common multiple. Please take note of that. All right. So let's look for the LCM of 5 and 9. Find LCM of 5 and 9. So what we have, if we write multiples of 5, we're going to have 5, 10, 15, 20, 25, 30. Multiples of 9, we'll have 9, we'll have 18, we'll have 27, we have 36, we have 45. So you can see we haven't gotten a multiple yet, and then we'll have 54. That means I'll continue writing 5. 30, we'll have 35. We have 40, have 45. Okay, I now have a common multiple, that's 45. We have a common multiple, 45, because 5 is there in 5, multiples of 5, 45 is there in multiples of 9. There is no need for me to continue writing. I'll just say LCM is equal to 45. Okay, I'm going to show you one other way, very simple way to find LCM. The problem is that there are certain numbers that you have to write a lot of multiples, very many multiples, before you can find the common multiple. So there's one way you can find LCM without writing a lot of multiples. Okay, one of those ways is by prime factor decomposition, but we won't necessarily go into that. I will show you one short way to find LCM. All right, so let's take the examples that we had already taken. Let's take the example. For instance, let's find the LCM of 5 and 9 using one other method apart from writing out the common multiple. Remember, the simplest way is to write out the common multiples and find is to write out the multiples of the numbers and then find common multiples and pick out the smallest. But like I said, many times or at certain times, you have to write a lot of multiples before you can find common multiples. So you can always use this. So what we'll do is write the two numbers 5 and 9, and then we are going to look for a number that can divide the two numbers at the same time. If we're not able to find such number, we'll look for a number that can divide at least one of the numbers in question. So is there any number that can divide 5 and 9? No such number exists. So we look for a number that can either divide 5 or divide 9. If we look for a number that will divide 5, that number is just 5 because 5 is a prime number. So if 5 divides 5, we'll have 1. Since 5 cannot divide 9, we're going to repeat 9. We'll still write 9. And then what we have here, 1, we just need a number that can divide 9. What is that number? 3 can divide 9. If 9 is divided by 3, we'll have 3. We'll repeat 1. Okay? And if 3 again divides 3, we now have 1. Okay? So what now is our LCM after doing this? The LCM is collecting these numbers that we use to divide. We use 5 initially, use 3, and use 3 again. So LCM will be 5 times 3 times 3. 5 times 3 is 15. 15 times 3 is 45. You see, I still got 45, but I did not have to write multiples and multiples and multiples until I got to a common multiple of 45. Okay, let's take one more example. Remember, these are preliminary things that you need to know to forge ahead. So let's take another example. Find the LCM of 7 and 11. Find the LCM of 7 and 11. Okay, so we're going to write 7 and we're going to write 11. And then we'll look for a number that can divide two of them at the same time. If we cannot find such number, then we look for a number that can divide either 7 or 11. The number that can divide 7 is 7. The 7 divided by 7 have 1. 7 cannot divide 11. We repeat 11. Okay, we now use 11 to divide. Here is going to be 1. If 11 is divided by 11, we have 1. So in this case, the numbers we're going to multiply are 7 and 11. So LCM is equal to 7 times 11. Very simple, okay? Very simple. So, what do you think? Let's take another example. Find the LCM of 10 and 30. LCM of 10 and 30. Okay, just like we know, you draw this line, I draw this line, and then you have 30, and then you have 10. Look for a number that can divide 30 and 10 at the same time. If you don't have, look for a number that can divide either 30 or 10. So 2 can divide both 30 and 10. If 2 divides 10, we'll have 5. If 2 divides 30, we have 15. Okay, a number that can divide 5 and 15 is 5. 5 divides 5, we have 1. 5 divides 15, we have 3. A number that can divide 3 is 3. We still repeat 1. 3 divided 3, we have 1. So the numbers we have here are 2 times 5 times 3. So this number will give us the LCM. And LCM will be 2 times 5, 10. 10 times 3 is 30. So LCM is equal to 30. Now this is a very clean method to find the LCM. So if you're solving fractions, you want to solve equivalent fractions and most things that have to do with fraction, this is a very, very efficient way to find your LCM. So next, we're going to look at HCF. HCF. HCF stands for highest common factor. Highest common factor. Look at that word. Factor is at the end, common is there, and then highest. You already know what a factor is. A number that can divide another number without a remainder. You already know what common means. It means that this factor is here and it's also there. And highest means the biggest number. So highest common factor is the biggest of the common factors. So let's take, for instance, if we have a question like find the HCF of 20 and 35. Find the HCF of 20 and 35. What we need to do is to find those numbers that can divide 20 and then find those numbers that can divide 35. So numbers that can divide 20 are 1, 2 can divide 20, 4 can divide 20, 5 can divide 20, 10 can divide 20, and 20 can also divide itself. Numbers that can divide 30, all of them, all the numbers that can divide 30 will include 1, okay, 2 cannot divide, 3 cannot divide, 5 can divide 30 because 5 times 7 is 35, 5 can divide 35 rather, 7 can divide because 7 times 5 is 35, and then 35 can divide itself. Now look at these two factors, the factors for 20 and the factors for 35. Do we have any factor in 20 that we can also see in 35? Yes, we have 1 because 1 is the factor of every number, and then we have 5. So we also have 5 here and 5. So the common factors are 1 and 5. Which of them is biggest? So we'll give a highest common factor, the biggest common factor. Between 1 and 5, 5 is the biggest. So HCF of 20 and 35 is equal to 5. HCF, highest common factor. Highest common factor. So let's find the HCF. Find the HCF of 50 and 70. 50 and 70. 50 and 70. So look for those numbers that can divide 50. Those numbers that can divide 50 are 1 as usual, 2 can divide 50, 3 cannot divide 50, 4 cannot divide 50, 5 can divide 50, 6 cannot divide, 10 can divide 50, 25 can divide 50, and then 50 can divide 50. Alright, so if we do the same thing for 70, we're looking at numbers that can divide. Remember, we're not writing multiples, we're writing numbers that can divide 70. So 1 can divide 70, 2 can divide 70 because 2 times 35 is 70. 7 can divide 70, 7 can divide 70, 5 can divide 70 because 70 ends in 0. Any number that ends in 0 can be divided by 5. So 5 can divide 70, and 10 can divide 70. 10 can divide 70 because 10 times 7 is 70. So 5 times 14 is 70. So which means 14 can divide 70. Alright, 35 can divide 70 because 35 times 2 is 70, and 70 can divide itself. I just hope I've written all the factors of 70. These are all the numbers that can divide 70. So we pick out common factors. Are there factors that can divide 50? You can also divide 70 here. Yes, we have 1, we have 2, we have 5, we have 10, and these are the common factors. Common factors are 1, 2, 5, and 10. Okay, so among all these factors, which of them is the highest? 10 is the highest. So HCF of 50 and 70 is 10. The highest number that can divide both 50 and 70. That is the highest common factor. I hope these few concepts are clear. We talked about numbers, talked about prime numbers, talked about factors. I've explained multiple. Okay, I have explained LCM. I've also explained HCF. Please, if anyone is not clear, take the video back and replay. Okay, take the video back and replay. They are all very clear. I've explained them in the simplest way you can understand. I'll see you in another video where I will still continue talking about the few things that you need to know before we dive deeper into our study in mathematics. Other subjects will do the same thing. I'll see you in the next one.